got a formula that tells you how to plot X, how to plot Y, how to plot Z. If you let something like a computer graph that for you, it plugs in a whole lot of points and creates a curve. At any point, you could make a tangent vector. The tangent vector is what we sort of expect it to be. It's the derivative vector of the original curve. So you need to find that to get any of the other things, because the next thing that in the flow of the definitions we talked about is, well, let's turn that velocity vector or that tangent vector into a unit vector. Well, you do the same thing that you do to make all unit vectors. You take the vector, you divide by its length or its magnitude. So that gives you t, which again is just tangent to your curve, but it only has length 1. Then there's a second vector that points kind of into the curve, like, so if your curve's going like this, it's pointing, it's pointing directly perpendicular into the curve.
Yeah.
And we call it the normal vector or the unit normal vector.
Just kind of the axis.
You find it by taking the derivative of the one you just found and make it a unit vector. So, that's like, so I would think of the normal vector as the derivative of the unit tangent vector, but make it a unit vector also. So that's what you're doing here, is you're dividing by the length of t prime. T prime itself is the normal vector.
Yeah.
You make it a unit vector by dividing by its length.
Okay.
And then there's a third vector that, following the right-hand rule, is perpendicular to those other two, and it's the cross product of those other two. And then the last thing that we've mentioned so far is a scalar. This is not a vector, but it's a number, and it gives you a measure of how curvy your curve is.
Okay.
And it's called curvature. It's found by taking the ratio of the magnitude of the unit tangent vector to the original derivative vector, and that's its original definition. This is equivalent to doing this, so sometimes what you've calculated or what you've been handed, it might be easier to use this formula, but they calculate the same thing.
Okay.
And then all this is just saying, well, if you are looking at this path as motion, then R prime is going to be treated as velocity vector. R double prime is going to be treated as acceleration vector. And again, the bigger K is, the curvier your curve is.